NASA built the fastest machine in human history, 430,000 miles per hour, and nothing else is even close. Not a fighter jet. Not the space station. A probe falling into the sun on purpose, behind a heat shield barely thicker than your thumb. The spacecraft is the Parker Solar Probe, a car-sized robot designed to do something no human object had ever done: fly through the outer atmosphere of the sun. Not orbit Earth. Not visit Mars. Touch a star. It is named for Eugene Parker, the astrophysicist who predicted the solar wind in 1958, and became the first living person ever to have a NASA mission named after him. He got to watch his theory launch into the fire he described. Parker launched on August 12, 2018, atop a Delta IV Heavy, one of the most powerful rockets flying. It needed that punch just to start falling toward the sun. The mission sounds simple and is anything but: get close enough to sample the sun's corona, the ghostly outer atmosphere you see during a total eclipse, and figure out why it behaves the way it does. Here is the paradox that drove the whole project. The sun's visible surface is about 5,500 degrees Fahrenheit. The corona above it? Millions of degrees. Hotter farther out. That makes no intuitive sense, and scientists could not fully explain it from Earth. Parker also hunts where the solar wind is born, the stream of charged particles that blows outward through the solar system. Parker's 1950s paper said the sun was not quiet. It was constantly exhaling. He was right. We needed a probe in the exhale to prove it. So why does falling toward the sun make you the fastest thing humans ever built? Gravity is an accelerator with no speed limit until something stops you. Parker dives inward on an elliptical orbit. The sun's pull converts altitude into velocity. But you cannot just point at the sun and go. Parker used Venus 7 times as a gravitational slingshot. Each flyby trimmed orbital energy and steered the spacecraft closer to the solar furnace. Think of it as stealing momentum from Venus's orbit to pay for a hotter ticket sunward. The last Venus assist in November 2024 locked Parker into its final, closest orbit, an 88-day loop it will ride for the rest of its primary mission. That orbit is a long oval, weeks far from the sun, then a screaming plunge inward every 3 months. Close enough to do real science. Far enough, most of the time, to survive. Survival is the engineering story. At closest approach, the sunside heat shield faces temperatures around 1700 degrees Fahrenheit. The shield is a carbon composite disc roughly 4.5 inches thick, the thermal protection system. Behind that disc, the instruments sit near room temperature while the front cooks. Light bounces off, heat radiates away, the spacecraft hides in its own shadow. It is less a spaceship at perihelion and more a very expensive umbrella surfing a thermonuclear hair dryer. During each close pass, Parker flies alone. No real-time commands. No chatty signal home. For about 9 days around perihelion, it is autonomous, programmed, then trusted, while Earth waits for a single tone that says, "Still alive." On December 24, 2024, Parker made history. It passed just 3.8 million miles above the sun's surface, closer than any human-made object, and survived. A beacon tone arrived December 26. Normal operations. Casual interstellar flex. 3.8 million miles above the solar surface, closer than any human-made object had ever flown. On cosmic scales, that is still terrifyingly near a thermonuclear sphere. At that pass, Parker hit 430,000 miles per hour, about 191 kilometers per second. Roughly 0.064% of the speed of light. Fast enough to cross the United States in about 20 seconds. The previous speed record belonged to Helios 2 in 1976, about 142,000 miles per hour. Parker nearly tripled it. The International Space Station crawls by comparison at 17,000 miles per hour. This is not incremental progress. It is a different category of motion, a spacecraft treating the sun like a gravitational racetrack and winning every lap it survives. If Earth and the sun were opposite end zones on a football field, Parker would be 4 yards from the sun's goal line, already inside the tenuous outer corona. Parker did not just fly fast. It became the first mission to sample the solar corona directly, flying through plasma that had only ever been seen from afar, touching the atmosphere of a star while moving at highway speeds for the solar system. The data matters because the sun is not a background light in the sky. It is a weather machine. Coronal mass ejections and solar flares can hurl billions of tons of plasma toward Earth. We have seen how bad it gets. The Carrington event of 1859 set telegraph wires sparking. A storm that size today would be a civilization-scale headache. Parker is our early warning scout inside the blast zone. When that plasma hits our magnetic field, satellites glitch, airlines reroute polar flights, and power grids can wobble. Astronauts on future Moon and Mars missions will live or die by how well we predict space weather. Lucky timing helped. Parker launched near solar minimum and has now flown through solar maximum, the peak of the sun's 11-year activity cycle, sampling quiet corona and stormy corona in the same mission. As of 2026, Parker has completed more than 24 close passes and keeps matching its own records, same blistering speed, same daring distance. Mission leads report the spacecraft remains in excellent health. Each pass is the same choreography, days of silence, a furnace dive, a beacon tone, then weeks of data trickling home. For instrument suites measuring fields, waves, particles, and the structure of the solar wind where it is born. Eugene Parker did not live to see every flyby, but he saw his nameplate leave Earth and his solar wind prediction confirmed in situ. The probe is as much a scientific instrument as a monument to asking uncomfortable questions about the sky. What happens after 2026 is formally under NASA review, extensions, end of mission, or new objectives. But the records already stand: closest to the sun, fastest human-built object, first to taste the corona. 430,000 miles per hour. 1,700 degrees on the shield. 3.8 million miles from a star. One heat shield. Zero margin for drama. We built a machine that falls toward the sun on purpose, because the answers we need are not on Earth. They are in the wind, in the heat, in the physics we could only guess at until something brave enough went to look. NASA built the fastest machine in human history, and sent it not away from us, but toward the thing that makes life possible. A star-touching, record-breaking, data-hungry proof that when the sun asks a hard question, we answer by showing up at 430,000 miles per hour. Thanks for watching. Subscribe for more amazing facts about our world.